Hello everyone, myself Sindhushree and I'm currently pursuing my second year engineering in Sri Venkateshwara College of Engineering. Today we are going to discuss a topic called Huffman code. Huffman code is a compression algorithm that allows us to compress data by replacing longer bit patterns with the shorter ones. Now let us explore how it works and its potential applications. Huffman code is a lossless comparison algorithm that compresses data without losing any information. It was invented by David Huffman in 1952 while he was a graduate student at MIT. Then, Huffman code was one of the earliest algorithms, and algorithms are played in a significant role in the development of modern data compression techniques. It is still widely used today, mainly in lossless image compression. Now, let us want to discuss the Huffman coding algorithm. The first step is initialize N1 node trees and label them with the characters of alphabet. Record the frequency of each characters in the tree's root to indicate the tree's weight. More generally, the weight of the tree will be equal to the sum of the frequencies in the tree's leaves. And the step 2 is repeat the following operation until a single tree is obtained. Find two trees with the smallest weight. Make them the left and right subtree of a new tree and record the sum of their weight in the root of the new tree as its weight. A tree constructed by the above algorithm is called Huffman tree. It defines in the manner described by Huffman code. Now let us discuss one example how the Huffman code works. Okay. Suppose a string below is sent to over a network. This is the string we have to send to the network. Each character occupies 8 bits. So there are total 15 characters in the above string. Thus the total size is 8 into 15 is 120 bits. So it is a little longer to transfer. So in order to compress this size bit, we'll use Huffman code. Then using a Huffman code, first we have to calculate the frequency of each character in the string. First step is to calculate the frequency. So how to calculate is, we have to count like how many B characters are there in the above string. Okay, B has only one character, so only one frequency. Then C, how many C characters are there in the above string? So C, there are 6 characters, so the frequency of C is 6. And A, how many A characters are there in the above string? So the frequency of A character is 5. And D, how many D characters are there in the above string? So the frequency of D character is 3. Next, we have to sort the characters in the increasing order of the frequency. Then we have to arrange the obtained frequency in the increasing order. Okay. Then at first we have to add the first two elements, like first two characters. So here, according to my example, 3 plus 1 is 4. I have assigned 4 as a new value. Okay, for 4 I have assigned a new character, that is star. When we add both the strings, it will get the value 4. Then the value which is minimum is placed to the left subtree, and the value which is maximum is placed in the right subtree. So as a given, first we have to add two elements and assign a unique value and arrange a minimum value frequency to the left node and the maximum valued frequency to the right node. Now again we have to perform the same operation. At first we have to arrange the given character frequency in the increasing order. So as per my example, the increasing order will be 4, 5, 6, 9. Okay. Then again we have to add 4 and 5. So these are the first two elements, no? So we have to add 4 and 5. The value is 9. But the 9 is bigger than 6. So we'll arrange after 6. Okay. Then we have to make a subtree, that is 9, 4, 5 and 1, 3. To the 1 is for the left subtree of 4 and 3 is for the right subtree of 4 and 4 is the left subtree of 9 and 5 is the right subtree of 9. Then we have to add the remaining elements, that is 6 and 9. Addition sum of 6 and 9 is 15. And then we have to arrange those values in the tree, that is for the left subtree of 15 we will place a value 6 and the right subtree of the 15 will place a value 9. Then this is the subtree we obtained by using a frequency. Then we have to add zeros and ones to the tree, that 0 for the left subtree and 1 for the right subtree. Okay. Then we have to calculate the code for each character. For A, it is 1 1. how means, see, A is here. We have to check 1 1. So for A the code is 1 1, and for B, where is B? Here. Okay, the code for B is 1 0 0. So for the code for the B is 1 0 0, and for C it is just 0, and for D we have to check 1 0 1. So for code D is 1 0 1. This is how we obtain a code for each characters. Then we'll see each values in the table. So for character A, the frequency is 5 and the code is 1 1, as I said in the before. Okay. Now the size is 5 into 2 is equals to 10. This is how means frequency is 5 and the code here one character here code has only 2 characters, so 5 into 2 it is equals to 10. And for character B the frequency is 1 and the code for B is 100. The size is 1, that is frequency, into 3, because here 3 bits are there, so 1 into 3 it is 3. Then for C the frequency is 6 and the code is 0, so 6 into 1. We'll not consider only 6 because even 0 as a bit, we have to include that also. So 6 into 1 is equals to 6. And for D the frequency is 3 and the code is 101 and the size is 3 into 3 is equals to 9. When we add all these, we'll get 28 bits. See how it is, how the bits are reduced. Okay. Now without encoding, the total size of the string was 120 bits. Okay, after encoding the size is reduced to, then after encoding all the character size, we'll get total 75 bits. Now next, decoding the code. Even we can decode the code. This is how means, if there someone is asked decode 101, according to our subtree where 101 is present, we have to check. See whether it is present here, no. Whether it is present here, no. Then whether we have to check 100. So B is not a character. Now 101. Hence we obtained the given question. What they asked, let 101 to be decoded. So we have to check where this 101 is present. So here 101. So the value is D. In the same way, they may ask the long string. They may ask 101, 11, 000 in a such a way. Then we have to see like how many digits are used and how the tree is there. This is the way how we decode the Huffman code. Now let us discuss the advantages and disadvantages of the Huffman code. Advantages is Huffman code is simple, fast and effective. It achieves high compression ratios and can handle any type of data including text, images and audio. Then the major disadvantages of this Huffman code is Huffman code is not always most efficient compression algorithm, especially for large files or data sets. It also requires knowledge of frequency distribution of the input data. So major disadvantages of this Huffman code is we have to require the knowledge of that what strings frequency. This is the major drawback of this Huffman code. And the advantages is they are most effective and they are used to save the storage and reduce the size of text, images, anything, even including audio. And this is the last sorry, this is the last slide of my video. And thank you for everyone for listening my video. Thank you.